I want to talk quickly about IPv6 versus IPv4. And I want to talk first about the benefits of IPv6 versus IPv4. Then I'm going to discuss uh, quickly this idea of favoring IPv6. So it is the future of the internet. You see, IPv6 uh, is the next version of the Internet Protocol, uh, version 4. There was no 5. And version 4 has this limitation that is a 32-bit uh, addressing, i.e., it's scarce. There's not many addresses. And this actually created another thing now. Everybody wants to buy IPv4s because they are so expensive and they are kind of commodity. They become a commodity, expensive commodity. And so that's one thing. But the limitation of this caused us to build technologies to circumvent this limit, right, of the whatever 2 to the power 32 32 addresses. So then what we built is, first of all, network address translation, because behind the router you can have thousands and thousands of machines. We couldn't assign unique addresses for each of those so they can be exposed to the internet, right? So we built this network address translation. We reserved private sets of IP addresses. If you've seen this 192, this is a private IP address. With 172, that's a private. 10.00, it's also a private. And this is specifically just for local areas. And then once you want to communicate with the public internet, i.e. being addressable, your router has a public IP address, just one, addressing thousands of machines behind it. Wi-Fi machines, fridges, iPads, anything, right? So then we built this translation to translate it. And that it has its own benefits as well. Then, but we built that because there is limitation in the IPv4. If the IPv4 didn't have limitation, we wouldn't have built that, right? So then IPv6 doesn't have this limit. It has literally trillions of addresses, right? So you can technically assign that. Now this will become interesting, right? Because I don't know if this is practical, to be honest. Right? Assigning unique addresses, you globally to any machine. Right? You would need some sort of a dynamic host protocol that assigns these IP addresses, right? So we established that IPv6 is, well, if you agree, it's better, right? And there are a lot of other benefits, such as, I didn't verify that, but there's like, it's more, it has, their headers is more efficient. So the parsing of these IP packets becomes more efficient at the router levels. I don't know how true is that. I need to look into it. But the whole thing that we're talking about here is IPv6 is the future of IPv4. But how do you force clients to use IPv6, right? There's absolutely no incentive. IPv4 just works, right? And if it's something is working, nobody was gonna switch to IPv6. So you have people building, and I don't have strong opinions about this, by the way, building RFCs, standards, to force people to use IPv6. One of them is the Happy Eyeball RFC. It's in the second revision right now. So what this does is, if you have a DNS entry that you resolved and you got back a set of IP addresses, right? You would have a record, which is the IPv4, and then AAAA, 4 A's for IPv6, right? So then the client is left with a choice. And then I specifically say the client code here, right? This has nothing to do with the kernel. It's just the client receives this addresses. He has choices. Which one should I connect to? It's an interesting choice, right? So most clients will just pick the IPv4, right? That's what they know. They know they work. Because IPv6, if you don't know, sometimes boxes in the middle might not support it, right? And you'll end up dropping connections. That might be true. That might have been true 10 years ago. I don't know how how widespread. I'm pretty sure I think it became widespread now, especially with the cloud days. There is a push to switch everything to IPv6, right? So this happy eyeball RFC, it says, well, try the IPv6 always first. If the connection is established, go for it and continue doing your business using IPv6, right? Knowing that all the routers in between are safe and good to go, right? They understand this protocol. If that failed for some reason, right? The middle router is unsupported, your packet didn't get there, your the actual server for some reason doesn't support it yet. It advertised it, right? So you get back this in the TCP handshake. You're gonna send a send. You're gonna get back a reset, RST. This is a reset that's very critical, by the way. And what the kernel gets this reset from the server, and the kernel's job is just to bubble that reset up all the way to the user space, to the client code, right? And then when it got that, the client choose, oh, server is not available. Now, I didn't see a straight implementation. Some clients will retry. Hey, let me try 3 times. Maybe it was just a fluke. You'll be surprised how much implementation is like, try again. Like if something's not working, just turn it off and turn it back on, kind of a situation, and it will work. And hey, I don't judge. I think sometimes things happen, and then all of a sudden it doesn't exist. That situation doesn't exist, and your connection will work, right? So retrying is not a wrong decision by any means. Now you can follow that and try to understand why it failed in the first place if you're interested. But so the client will keep retrying, or we just, and I don't want this IPv6 business. Let me switch to IPv4. Right? So it's interesting, and then you communicate. You can finish the connection, and the new happy eyeball RFC says, because let's talk about the problem with this one. This problem is there's a delay. Well, now all I wanted to go is to this website. I'm seeing delay. Yeah, it might not be but sometimes it is like a second, 2 seconds before my connection gets established. And that's because if the IPv6 endpoint is not available for some reason, right? It's just because, remember, the DNS server giving you these IP addresses does not know that the server actually is actively listening or not. At some point it did. It says, hey, I'm server that I support these 2 IP addresses, IPv6 and IPv4. Trust me, bro. So localhost, not localhost, the localhost is also a domain, right? Entry, so you can resolve to both if you want. The localhost is ::1, that's the IPv6, 127.0.0.1, that's IPv4. But it applies to any domain, really. So that's what happens, right? You're going to switch to that, and there's a delay. So the RFC has been updated to say, no, you're okay, we understand. Now there's like this delay. Let's establish connection both ways. Let's connect to the IPv6 and 3 and to the IPv4 at the same time, concurrently. Well, now you're asking the question, okay, what if both succeed? Well, if take the common scenario where IPv6 fails. I don't know if it's that common. Well, IPv6 fails, then IPv4 succeeds. Well, you would know immediately, right? Because IPv4 succeeded, IPv6 failed, you didn't delay anything. You will just ignore IPv6 and continue with the IPv4. The problem is if both succeed, what do? Right? If both succeed, then you would continue the IPv6 and you have another active connection on IPv4, right? Now you have to close the connection there, right? Because you don't know, right? IPv6, someone, the port that you're connecting to is just not there, like not listening, or that server went down for some reason, right? So that's what's gonna happen. So this, I think, is a little bit of a resource intensive, right? If you think about it. Now, all of this in the internet, maybe I'll kind of agree with. All right, let's go IPv6 on the internet. However, local host, I don't know if I locally it's the same behavior. Local host, the string local host, can also reserve to both. So in that particular case, I don't think you need to do this happy eyeball at all. It's just, hey, just don't ignore IPv6 altogether, or do the minimum thing, right? But it might be difficult to code the clients in such a way that, all right, make an exception for local host versus not, right? And that's, you'll be surprised. I've been in meetings like this, with seniors, and everybody will have a different opinion. All the opinions I'm telling you will be countered left and right. If you've been in one of these meetings, I'm sure some of you will have. And then you will just hear how people argue about all of these things, and there is no solution to any of it, right? One solution is just, hey, when I'm listening only on IPv4. I know I don't have an IPv6 entry at all, right? If I'm listening, I'm just giving the iNet family IPv4. I'm not listening IPv6. I know that. So I need my clients to have this knowledge. So my DNS will never advertise IPv6 at all, right? So if you do, that's a mistake, right, on your end, right? So you have to understand all this stuff, right? Especially even if you have Cloudflare. Cloudflare will advertise both, right? But it's your responsibility to listen on the IPv6 so that you don't have this delay, right? But at the end of the day, you could configure your host system to be IPv4. So say, yeah, I'm just using IPv4, or I'm just using IPv6. And as a result, you configure your whole system as this server. But if you want to connect, even like localhost, sometimes it's faster to use 127.0.0.1 versus using localhost, like HTTP localhost versus HTTP 127.0.0.1. It's faster, right? First, there is a cost of DNS. It's not much, right? Because most the DNS doesn't really go anywhere. It goes either locally, checks this host file, so there is a read to the memory, right? The file, you're going to file, the file cache in the OS. So there is a microsecond. It's not much, right? And it's cached. But then the real cost is this decision that the client code needs to do. It's like, oh, localhost is resolved to two things, IPv6 and IPv4. So which one should I connect to? So, and I'm gonna leave this to another video because this video is already long, right? And I need to get back to my dog. Windows behave differently even. Right? In Linux, when you connect to an entry, when I say connect, I'm connecting to a port, of course, right? You don't just connect to an IP. That doesn't make sense. Connect to a port, right? And then that port is not available. You'll get a reset from the server, and the kernel, the Linux kernel, will just bubble it up to the client. Says, hey, you got a reset. So you do whatever you want to it. Windows says, no, this might be a fluke. Yes, we got a reset, but the kernel itself will try to retry. Actually, Daniel Stamberger talked about this the other day, has a blog about it. I'll try to reference it in this video. This is my second channel anyway, so I'll reference that. I'll reference that video here. I put videos like this, casual videos that I just have an idea and talk about in this channel, right? When I want a little bit more polished videos, I put them in the first channel. But yeah, essentially, yeah, he talked about this, and there's a huge delay in Windows because the client never got this reset. So the client's actually waiting for the decision to even decide to connect to the IPv6 or not, right? It doesn't know that the IPv6 is not available. it's just the Windows will just retry, and it will retry for seconds before it goes back to the client and then says, oh, it's not available. Now, whether this decision from the Windows kernel is bad or good, again, you could argue with, you will be sitting in a table with people, and everybody will provide valid opinions about this retry in Windows, and that how is not will not change. And I guarantee you, if you remove that retry, this loop in the kernel, billion things will start to break, 100%, because some logic, some bad client code relied on the fact that, oh, I don't want to retry. I'm the client, the Windows is retrying for me, and you don't want to break clients. I think this is one rule, that you never break client code when you build kernel applications. All right, guys, I'll leave you at that. I just wanted to talk about that. See ya.